Let's look at problem 323, number of connected components in an undirected graph. So for this problem, we're going to provide a Unifent solution. So this problem actually is identical to problem 547. I would say the same code, almost the same, will solve the problem here. First, I will go through the statement of the problem. Then we will look at the method and the main procedure. And finally, we give the solution and test the generic cases. First, let's look at the problem. So we have a graph of n nodes, and we are given an integer n and an array edges, where edges I equals AI and BI indicates that there is an edge between AI and BI in the graph. So the return for this problem is the number of connected components in the graph. So here are two examples. So in example 1, there are two connected components. And in example 2, there is only one connected component. So let's look at the constraints about the problem. The first one is about the size of the m, which is greater or equal than 1 and bounded above by 2000. Similarly for the edges, which is bounded above by 5000. And AI and BI are not the same. And also there are no repeated edges. With the constraint finished, let's look at the method and idea. The method we're going to use is a Unifent method. So the idea and the procedure is as follows. First, we put all nodes connected into a cluster, represented by an element, or call it a root, and then we count the number of distinct roots or representations. So here is one example corresponding to example 1. So in example 1, there are 5 nodes, and we group them into 2 groups. One is 0, 1, 2, has a root 0, and 3 and 4 has a root 3. So together there are 2 groups, in other words, 2 distinct roots, 0 and 3. So we return 2. And that's about the main idea. So how do we put all this together or do the grouping? That's exactly the effect of the union operation we are going to implement. So before we look at the code, maybe it's good to practice some similar problems. For example, Leetcode 547 and Leetcode 990. So problem 547 is almost identical to this problem here, and problem 990 is a little bit indirect, but still not hard for us to try. So now let's look at the solution. For this, I'll first make a preparation. So make preparation. Because there are n cities, we will initialize a root directory, so called II. Initially, for each index, we set its parents by itself. So for I in range n. So here the pair basically is the index and the parents pair. So step 2 basically is an implementation of the Unifent hyperfunction. So for this, I'm going to first look at the Fent method. So Fent, the input is one index. So we're going to return I if I and its parents are the same. Otherwise, we make a recursive call, and we do the same operation but for roots I, in other words, the parent of I. So that's it about the Fent operation. So now let's do the union operation, so which accepts 2 arguments, say ig, representing 2 cities, and then we first track the root for them. So here is I. Then if Ri does not equals Rg, so we want to group them together. So this actually is done by this operation. So by setting the Rg has the root, let's say Ri. So that's about it. So now the problem itself asks to return the number of connected components in the graph. So let's implement another hyperfunction just for convenience. So we want to return the number of connected components. So for this, I will first initialize a dictionary, and then we iterate over the final state of roots for key v in roots atoms. So we want to first track the root of this v, so using the find function. Then we check if root is inside or not in the D. So if the root is not in D, we're going to set D root as this set given by key. Otherwise, we're going to update the corresponding set by adding key. So with that done, what we are going to return is the length of D. In other words, the different roots. That's the number of connected components. So with that said, we are ready to move to next step. That is the actual work. For the actual work, we're going to traverse the edges list. So basically for ij in edges. Because this represents a edge, so we want to union these two cities, just the union ij. So that's actually the actual work. So now, once we've done the actual work, basically we are ready to return the final result. So for this, we just need to make a call for components, right? So that's the full code for this problem. So let's overview it. It consists of roughly 4 steps. The first step is basically a initialization, and the second step does not do the actual work, but it's some helper functions. One is find, one is union, and one specific to this problem to get the number of different components. So third step is the actual work. We want to group all the cities connected together. And the last step is the return. So let's check for the 2 test cases and then generic case. So in this case, we are writing to, return 2 as expected. Actually, we can print out this D just for clarity. So if we run it again, so you see these are the 2 connected components and their representations. And let's also look at the second example. So we have edges and n equals 5. So in this case, so we get one connected component. This is the component, and this is the representations. So with that said, let's comment out this print and check the generic case. Oh yeah, it passes the generic case. I guess that's about it for this problem. So it's good to try some similar problems to explore the power of Unifent. Thank you very much.